This is Engage New York, Module 2, Lesson 3. Read the objective while I read it. I can write and interpret numerical expressions and compare expressions using a visual model. So, to interpret means to figure out what it's actually saying, and a numerical expression means a number expression. Remember, an expression does not have an equal sign. An expression does not have an equal sign. And your ability to compare those two. Now, we're going to start with fluency. We're going to start by multiplying multiples of 10. Then we're going to estimate products, just like we were doing yesterday. Then decompose a factor using the distributive property. So here's an example. How do you pull that apart and then multiply? Finally, it is our application problem. Robin is 11 years old. Her mother, Gwen, is 2 years more than 3 times Robin's age. How old is Gwen? So this is what we're going into today. Her mother, Gwen, is 2 years more than 3 times Robin's age. How old is Gwen? So this is our fluency. Then we will start with our concept development. All right. Go ahead and begin. We will come back in about 10 minutes and check. All right. So when we multiply multiples of 10, I broke it up 21 times 1 times 4 times 10. And it was 84 times 10. It was 840. Then I have 213 times 1 times 3 times 10. It's 213 times 3 times 10, which is 639. And then 639 times 10 is 6,390. Then we have 4,213 times 1. And then I broke it all the way up in expanded form. So we are going to do 4,213 times 1 times 2 times 10. Then breaking it down, 2 times 4,000 plus 2 times 200 plus 2 times 10 plus 2 times 3. And then there's going to be one. We're going to multiply by 10. We can't forget our multiply by 10 at the end. So then we get 8,000 plus 400 plus 20 plus 6. So it's 8,426 times 10, which becomes 84,260. So then estimate the product. So estimate it to 400 times 20. It's 4 times 100 times 2 times 10 becomes 8 times 1,000, which is 8,000. Then we have 300 times 20. So 3 times 100 times 2 times 10, which becomes 6 times 1,000, which is 6,000. Then we have 2,000 times 40. So it's 2 times 1,000 times 4 times 10. 8 times 10,000 is 80,000. Then we have 2,000 times 30. So 2 times 1,000 times 3 times 10 is 6 times 10,000, which is 60,000. All right, decompose a factor, distributive property. So 9 times 3 is 27, which we know. So now we're going to break up the 9 into something smaller, more bite size. So 5 times 3 plus 4 times 3. So I broke up 9 into 5 and 4. That's where that came from. So 5 and 4. So 5 times 3 is 15 plus 4 times 3 is 12, which equals 27. Then 7 times 4 is 28. But another way of doing it would be to break up 7 into 5 and 2. And then go 5 times 4 plus 2 times 4, which becomes 20 plus 8, which equals 28. Then we have 8 times 2, which is 16. And if I break up 8 and go 4 and 4, So 4 times 2 plus 4 times 2 is 8 plus 8, which is 16. Finally, 9 times 6 is 36, but if I break 9 up into 6 and 3, and then go 6 times 6 plus 3 times 6, I end up with 36. Whoa. 6 times 6, 36. Oh, this should be 54. Ah, 54. 54. All right. Finally, our application problem. Robin is 11 years old. Her mother, Gwen, is 2 years more than 3 times Robin's age. So if we know Robin's age and we know Gwen is 3 times Robin's age plus 2 more, then we know it's 11 plus 11 plus 11. It's 3 times plus 2 more. She's 35 years old. How'd you guys do on that one? Good? Woohoo! Really fast, Jose. All right, we're moving on to concept development. This is a concept that I really, really like. I hope you guys end up liking it as much as I do, but I really, really like this concept. I don't know. It really makes sense to me. Words, like the words and the numbers and the way they go together, and it tells you exactly what to do first.